Hello, children. So this is the polynomial recap series. And in this video, we are going to start solving the best PYQs from the chapter Polynomials for grade 10. So it's my request that every question, take a pause for 2 minutes, try to solve, and then check the answer when I'm sharing the solution. So let us look at the first question here. So this is the very basic and the most important or the first category of the question wherein the polynomial will be given and you need to find the zeros. So we all know that when the polynomial is given to us, so in order to find the zeros, we first equate the polynomial to 0. So I'll take the LCM. This will become 21y square minus 11y minus 2 by 3 is equal to 0. And anyways, denominator 3 equal to 0 means this 3 will go to the right hand side. So your polynomial will eventually become this. Now you need minus of 21 into 2 as the product. So you need to find two numbers which add up to minus 11y and multiply up to minus 42. So you all know the way. So 21 is 7, 3, and then this 2 from here. So maybe you can think of 14 and 3 here. So we can write as 21y square minus 14y plus 3y minus 2 is equal to 0. Taking 7y as common, 3y minus 2 plus 1 into 3y minus 2 is equal to 0. So this becomes 7y plus 1 into 3y minus 2 is equal to 0. So y is equal to minus 1 by 7. Y is equal to 2 by 3. So this will be your option D. So now moving on to the second one, which is assertion and reasoning. This came in 2025. Degree of a zero polynomial is not defined. So we know that, yes, this is a true statement. For zero polynomial, degree is not defined. Degree of a non-zero constant polynomial is 0. This is also true, but this doesn't reflect the reason of why the degree of a zero polynomial is not defined. So let us have a look at the question number 2 then. So a zero polynomial means if your px, py or whatever is 0, so that means getting an output of 0 can be with any degree. It can be x to the power 3. It can be x to the power 2. So anything that gets multiplied with 0. So basically we cannot specify in particularly what degree of the polynomial will it be. So that is why the degree of the zero polynomial is not defined. And yes, degree of a non-zero constant polynomial. So we know that, like, if let's say any constant variable I'm taking, any constant number I'm taking, let's say as 7. So its degree is 0, because now this means if you try to bring the x here, it should be x to the power 0. Because x to the power 0 is 1, in that case only px is equal to 7, because x to the power has become 0. So degree of a non-zero constant polynomial is 0. That is also true. But reason is not the correct explanation here. So I'll go for option B. So now quickly move on to the third one. This is another important categorization of question here. If one of the zeros is given, so whenever polynomial is given to you, let's say px is equal to k minus 1 x square plus kx plus 1. Now 0 is given as minus 3. So what I will do, I will substitute minus 3 in my polynomial. And then since I know that this is a 0, so that means the remainder should come out to be 0. So that's the factor theorem. So then what I will get here is 9 into k minus 1 minus 3k plus 1 is equal to 0. I'll just solve it quickly. Minus 3k plus 1 is equal to 0. So this gives me 9k minus 3k, which is 6k minus 8 is equal to 0. So children, k is equal to 8 by 6. So k becomes equal to 4 by 3, option A for this one. So then quickly moving on to the question number 4, the degree of polynomial having zeros as -3 and 4 only. So now in this question, they have clearly mentioned that you have two zeros, -3 and 4 only. So that means it is going to be a quadratic polynomial, degree will be 2, because we know that at most two zeros are there. So degree will be 2 here. This is very simple. Then the next question is that two polynomials are shown in the graph, the number of distinct zeros. So both the polynomials, right, are cutting at two distinct points on the x-axis. So this is your -x here. This is your +x here. So the number of distinct zeros of both the polynomials will be 2 here. Thank you so much, children. I'll share the next video soon.